I am going to teach you how to use a ratio table when you're dealing with large numbers. Here is our example problem. Japan has 127 million people and 150.82 million phones. What is the number of people per phone? What is the number of phones per person? As you can see, this problem actually has two different problems you have to solve in order to be done. But the first step you have to solve is to get normal numbers, which is standard notation, because I can't type 127 million into my calculator. Not with words anyway. So what I need to do is turn them into regular numbers. The way I'm going to do this is I'm going to look at the word million. Now I'm going to go to where the millions place is. So here I have my ones place, then my tens place, then my hundreds place, then my thousands place, then my 10,000s place, then my 100,000s place, then my millions place. And I could keep going, but I'm going to stop here for now. Now, if this was only 7 million, my 7 would go here. If this was 27 million, I would have a 2 in the 10,000s place and a 7 in the 10 millions place and a 7 in the millions place. But this is not 27 million, this is 127 million. So I need a 1 in the 100 millions place, a 2 in the 10 millions place, and a 7 in the 1 millions place. Right now this looks like I just have 127, which doesn't make any sense at all. So I have to put in my zeros as my placeholders to show that I don't have anything in those place values, but they still count. Then I put in my commas. Starting from the right, I count 3 spaces over and put a comma, 3 spaces over again and put a comma. So I have 127 million. That one's not too bad. The next one's a little bit harder because there's all these extra numbers. So I basically have 150 million and change. So, again, if I had 0 million, I'd have a 0 in the millions place. If I had 50 million, I'd have a 5 in the 10 millions place, a 0 in the millions place. And if I had 150 million, then I need a 1 in the 100 millions place, a 5 in the 10 millions place, and a 0 in the 1 millions place. Now the 8 and the 2, they can't just get chopped off. They follow whatever place values come next. So that means the 8 must be in the 100,000s place, the 2 must be in the 10,000s place, and I've still got all these blanks again. So I have to use my 0 as a placeholder because there's nothing there, but I have to show there's nothing there. Then I do my commas. Again, I count 3 spaces from the right, put my comma, 3 spaces from the right again, and put my comma. So the numbers really aren't that different from each other. The first one is 127 million. The second number is 150,820,000. Now we can finally solve the problem because we have numbers that can go into our calculator. This page is where we're actually going to solve the first problem. Now that we know what the numbers are, we can put them into a ratio table. But we need to figure out how to set up our ratio table. Because the question says people per phone, the way that makes the most sense is to put people on the top and phones on the bottom. It doesn't really make a difference which way you do it as long as you're consistent and you can figure out how to set up the problem, but it's generally easier to put the first word on top and the second word on the bottom. So I'm going to fill in the number of people. I know I had 127 million people, so I'm going to write 127 million, and I'm writing this in standard notation because in the last step I already fixed it to make it standard notation. My number of phones is 150,820,000. Now the question is, am I looking for one person or one phone? So then I go back to the problem where it says, what is the number of people per phone? Notice how phone is singular, so that means I'm looking for one phone. So my 1 goes here. Now how do I get from this horrible, ugly number to 1? The easiest way to get rid of any ugly number is just to divide by it, because any number divided by itself is going to give you 1. So I simply do 150,820,000 divided by 150,820,000. But because I want to keep the ratios the same, I have to actually do the exact same thing on the top in order for it to be fair. So if I'm dividing by the crazy number on the bottom, I'm also dividing by 150,820,000 on the top. And here's where I'm going to need a calculator. In my calculator, when I type in 127 million and I divide by 150,820,000, I get a really ugly number. I get 0.84206 and a whole bunch of other numbers. Now, I know the easiest way to set up my problem and to get an answer that makes sense is just to make it look like money. So I go 2 decimal places and then I draw a line separating it. I need to look at this number to figure out what to do with the 4. So the 2, because it's a nice little number, anything less than 5, that means I'm leaving the 4 alone. So my answer is 0.84. So that means Japan has an average of 0.84 people per phone. Now, that's not the way we typically solved a problem before. Normally, we have a bunch of people sharing one phone, like we did in Micronesia and in Tonga. But here in Japan, all of a sudden the number is smaller than 1. That's kind of confusing. I think I'm going to solve the other problem so I can try to figure out why this makes sense. So let's go to the next problem. For the next part of the problem, it wants us to find out the number of phones per person. So because it's phones per person is my 1, so I'm going to put phones on top and people on the bottom. Again, the order doesn't matter as long as you're consistent and you do all the work in a way that makes sense. So I'm going to fill in my numbers again, being very careful where to put my numbers, because I changed the order this time. My number of phones is 150,820,000. My number of people is 127 million. As I told you before, because person is the singular word, that means that's the thing I want one of. So one person. So that means I'm trying to get from 127 million to 1. Wait, how do I get rid of an ugly number? Oh, right. I divide by it. Any ugly number divided by itself will get you to 1. That doesn't only work for ugly numbers, but it tends to be the best way to do it. So 127 million divided by 127 million is going to give me 1. But if I do that on the bottom, I have to do the same, you guessed it, on the top. So I'm going to do 150,820,000 divided by 127 million. And again, this is when my calculator's going to come out. I'm not dividing these ugly numbers in my head. Now when I do this in the calculator, you guessed it, I got another ugly number. This time I get 1.18755 and some more extra numbers I don't really need. And as always, I want to make it look like money, so I go 2 decimal places and draw my line. This 7 tells me what to do with the 8. And anything that is 5 or more bumps the number up. 7 is obviously bigger than 5, so 8's going to bump up. So I'm going to end up with 1.19. So that means that Japan has an average of 1.19 phones per person. Well, that's actually starting to make a little more sense. Because in the last problem I saw that I had less than 1 person sharing each phone, which I never had before. But now I see that each person actually has more than 1 phone, so they don't have to share, which is different from what we've seen in Micronesia and Tonga. The main thing you have to see, though, is depending on how you divide, you're going to get completely different answers. So it's really important to pay attention to how the question is worded. Are they looking for people per phone or phones per person? Because depending on how they ask the question is going to affect what kind of answer you're going to get. Thank you for listening, and good luck.